Week 17, we're doing more geometry. Okay. We're going to cover some new topics that we didn't do last week, but are really, really important. And especially for not just now, but like in the future, right? And when you go to high school, you're going to need these things. So we're going to do a quick review of last semester's topics. It's just going to be like 2 minutes. We're going to do power of a point, mass points, and then some general problems. Now, but most of those will focus on these 2 new concepts we'll learn today, which are power of a point and mass points. Those are the 2 new things we'll do today. They're pretty advanced topics, okay? So don't be afraid if it's a little bit difficult, but they're pretty advanced. Start with review. I have this link here. I sent it through the WeChat last week, like yesterday. I can send it back here. So that's basically, I made a summary sheet for all of you. It's a sheet with all the geometry formulas we did last semester. And yeah, to open that, you need to use, you can't use your school email account. You have to use like your mom's or your dad's, okay? So this is 13 pages long. It's full of diagrams and stuff. And I spent time to put that together for you guys. So you can just use that to review because we went over a lot of geometry last semester. So I want to make sure that you guys have access to those review materials when you need them. Okay, so make sure you have that. If you don't, you might be a little bit sad. So that's basically our review today. We're not going to do much review. You can just look over that if you want. I'm going to go to power of a point. So what is power of a point? It's not a point that has lots of power. A point that has lots of power is like a black hole or an electron, right? Those things have power. But like when we say power of a point, these are equations which relate the lengths of segments in and around a circle. So before we do power of a point, we have to define some names. This is a radius. Radius, as you probably know. If we draw this one, it's a diameter. And then we've got a more general case. So we would take any 2 points in the circle, any 2, I'll do these 2, and then connect them. This is called a chord. A chord, like C major chord, same word, but different meaning. A chord is a line connecting any 2 points in the circle, which means the diameter is basically a special type of chord. Then we've got tangent. We know that already. A tangent is a line that hits the circle at only 1 point. A secant is a new one. So it's like this. Secant is a line that crosses through 2 points in the circle. This is a secant. Okay, this is a secant. We can have lots of secants. You just need to pass through 2 points. A chord is not a secant. A secant is a line, which means it goes on forever. It has part of it outside the circle. A chord has to be inside the circle the whole time. So those are our definitions. So now we've got some cool formulas. If we have any 2 chords in a circle, they will intersect. These are 2 random chords here. And they intersect. So let's say this length is A, this length is B, this length is C, this length is D. Okay. And the first power of point formula is AB equals CD. We do the length of A times the length of B, that equals the length of C times the length of D. Okay. So why does this work? Let me prove it to you. It's all our power of a point formulas are based on similar triangles. So for one, we know that these 2 angles are congruent because they're vertical angles. What else do we know? These 2 angles are congruent. Why? Well, you think about it. Let me use the different color here, red. This arc length. This angle cuts out that arc length on the circle, right? This angle. This angle cuts out the same arc length, right? And what do we know about the formulas involving arc lengths in a circle? We know that if the angle cuts out, let's say the arc length is x, then any angle on the circle that cuts out that arc length is x over 2. These are our angles in a circle formulas, right? So these two angles are congruent, which means that, let me use a different pen now. These two triangles are also congruent. They're not congruent, they're similar. So let me use this pen. These two triangles are similar by AA similarity. They have two angles that are congruent. Okay, so if we have AA similarity, the ratio between corresponding sides are equal. Basically, this means that A over C equals D over B. You see how that works? A is the side of the big triangle that's between these two angles we call congruent. C is also that angle. D is the one that's opposite this angle. B is the one that's opposite this angle. So basically, if A over C equals D over B, which means that if we multiply, cross multiply, we have AB equals CD, and that's our PowerPoint formula. This is the first one. If we have any two chords inside the circle, they cut each other at AB and CD. And AB, must remember, these are from one chord, and these two lengths are from the other chord. AB was on this chord. CD was on this chord. They have to be on the same chord to multiply. Now we've got some more formulas. We have two secants. Let's say I have two secants here. Two secants are cutting the circle at 2 points each. Say this is point P, A, B, T, C. So those are our points. The formula we have is PA times PB equals PC. Move this aside. PC times PD. Okay, so if we take one secant and we multiply the whole length like this, and we multiply by the length outside the circle, that's a constant value for any secant we have in the circle from this point, okay? PAPB equals PCPD. You can also find these in the geometry summary sheet I gave you guys. These PowerPoint formulas, they're all on the sheet, so you can refer to those. They're under circles, the circle section. So you can look for that. PA, PB, PC, PD, okay? The proof for this one, very, very similar. We're gonna draw these two lines. These two angles are congruent. Why? Because they cut out the same arc. They both cut out the arc BD right here, which means that these two angles are congruent, and they all share this angle. So we have these two similar triangles now. This one and this one. Two similar triangles, which means that if we write out the similarity equation, we have PDA is similar to PBC. Make sure that you're doing this in the right order, though. These letters have to be in the right order. We're doing P to D to A. It's like this. Naturally, we would have to do PBC for the other triangle. So PDA is similar to PBC, which means you can just do PA over PC. The ratio of corresponding sides are equal, right? PA over PC is PD over PB. If we cross multiply again, PA, PB equals PC, PD. That's the formula. Well, we have one last one. Just if we have one secant and one tangent. This line is tangent. It hits the circle at only one point. Okay, let's say this is P. Let's do P again. P, A, B, C. Those are our 3 points, 4 points actually. And we have the following equation: PA squared equals PBPC. You can notice how for the secant we did the same thing. We multiplied the shorter angle, the shorter length outside the circle times the whole thing. Whenever we have secants, we do that. For tangent, we actually squared the tangent. But this formula actually comes from the secant formula, the two secants formulas, right? Because if we look in at the tangent, if we zoom in really, really close, we can pretend that intersects the circle at like this. Like the arc of the circle goes like this. We can pretend, okay? And this is the tiny little length, say this little tiny little d. So basically, if we pretend that this is a tangent, it's basically a secant, except this length here is extremely, extremely small. So when we zoom out, it just looks like one point. So basically, if this tiny length here, we can pretend that the tangent is actually a secant. Okay, this is L, then we have L times L plus D, which is L squared plus LD. If we take the secant formula, right, we're taking this length times the whole thing. I'm taking just L and I multiply by L plus D. And I get L squared plus LD, but LD is so small. If I pretend at a tangent, if it's like almost a perfect tangent, the D is extremely, extremely small. We can basically say it's 0. So this term goes away. All we have left is L squared. So this tangent formula actually just comes from our secant formula. It's just that a tangent is basically a secant, except this length here that intersects the circle in is very, very small. It's 0, basically. Any questions about these 3 formulas? Cool. Now we'll go on to mass points. This is a very, very intuitive, very powerful strategy to solve problems with similarity in them. Okay, so think about seesaws. If you have a seesaw, right? If you have a seesaw and you had 2 people on the seesaw, let's say one of them was 3 times heavier than the other one. Okay, so if we had some guy that was M and the other guy was 3M, then if they sit on a seesaw, just a regular old seesaw with a pivot right in the middle, so this is 3M and M, obviously it would fall this way, right? It would not balance. So what would you need to do to balance it? Well, you have to move the pivot. You move the pivot closer to 3M, right? If you move it closer to 3M, then it balances. Because you have to move the pivot closer to the heavier guy. All right? So basically, this is mass points. If we have 3M and M, we have to change the length here so that this length is 3L and this length is L, right? We have to have the guy that's lighter 3 times as far away from the pivot as the guy that's 3 times heavier, right? So this is how we would balance the seesaw. And what's the weight on the pivot? Like what's the, if you're at a pivot, what mass are you experiencing? Well, essentially you're feeling 4M pushing down on you, right? Because you have to carry the 3M and the M. So basically, this is how mass points work. We think about seesaws. So let me give you an example here. We use this for a triangle. So in the following diagram, we want to find EF, FC, and AF, FD, those ratios. If we pretend that AB is like a seesaw, and E is the pivot, we have a length of 4 and a length of 3. So obviously this length is longer than this one, which means that we need a heavier guy here and a lighter guy here. And how we would do this is we could put a guy with 4M here and 3M here. Then it would balance, right? This guy has to be 4/3 times heavier than this guy. Does that make sense? So basically you have the seesaw here. And what's the force on the pivot? pivot experiences a force of 7m. We have to add the two masses on the two sides to get basically the weight on the pivot here. So basically what we would do is we would say, oh, A has a mass of 3, B has a mass of 4, and E has a mass of 7. Because that's how it would balance, right? Because A and B, A is 4 away from E, B is 3 away from E, which means that B has to have a mass of 4 and A has to have a mass of 3. And since E is in between them, we add the two weights on both sides to get 7 in the middle. Okay, now let's do the same thing here. This is another seesaw. B is one guy, C is the other guy, and D is the pivot in the middle. So how can we balance this? Well, intuitively, you would have to have C as heavier because he's a smaller distance away from the pivot. But by what proportion? You do 4 times 5 over 2. Because this guy here is 5 over 2, right, like 2.5 times farther away from the pivot than this guy. So this guy has to be 2.5 times heavier. So you do 4 times 5 over 2. This guy is a mass of 10. C has a mass of 10. For D, you would have to, it's the pivot, right? So we add masses on both sides. So this is 14. D has a mass of 14. So now we need to find EF, FC. What's the ratio? Well, look here, we have another seesaw. EFC is another seesaw, right? So F has a mass of 17, right? So basically now what we have here is what is EF to FC? If we pretend this is a seesaw, this side is shorter. No, this side has to be longer because it has a mass of 7 on this side. This side has to be longer because he has a heavier one. Oh wait, this side has to be longer. This one has to be shorter. And the proportion those have with each other is 10 to 7, right? The ratio of the lengths is equal to the ratio of the masses, because that's how you would balance it. So we would say that this length, if we say this is x, then this one is 10 over 7x, right? So what is EF to FC? Well, EF, we said that's 10 7x. FC is just x, which means that the ratio is that. Right? And we have ratios where basically you make fractions. And this simplifies to 10 over 7, or basically 10 to 7. This is the ratio for the first one. Okay, so now we're going to have AF to FD. A has a mass of 3. D has a mass of 14. Obviously, AF has to be the longer one. DF has to be the shorter one, right? Because A is lighter than D. And what's the proportion? Like, what's the factor between the lengths? What's the ratio between the lengths? The ratio between the masses, right? Because that's how you would balance it. So you would say that if this was x, the shorter one is x, then the longer one is 14 over 3x. The long one has to be 14 over 3 times longer to balance it. So what's the ratio of AF to FD? Well, AF, we said, is 14 over 3 because it's the longer one. FD is x. So basically, we have 14 over 3x over x, which is just 14 over 3. Or basically 14 to 3. That's the answer to this one. So this is all about balancing, right? If you have some guy that's x times heavier than the other guy, the lighter guy has to be a distance x times greater from the pivot than the heavier guy. Does that make sense? Any questions? Make sure you understand this because this is pretty confusing and pretty advanced, but it will make your life a lot easier for a lot of problems. Any questions? No? So you basically have, whenever you have lines intersecting each other, you have seesaws, okay? And then the heavier guy has to be a shorter distance away from the pivot, and a lighter guy has to be a greater distance away. So you set masses for these, and then you can figure out the proportions between the lengths of the sides. All right, let's do some problems. Find x in that diagram. These are all PowerPoint problems, so we're not on Mathcounts yet. These are for PowerPoint. 3 minutes. And chat me your answer when you get it. Okay, so the first one we're going to do is we're going to use the chord formula. These two chords are intersecting. The first chord has been cut into 6 and x, so we got 6 times x. This has to equal to the two parts of the second chord multiplied by each other, so 4 times 8. You will get x equals 16 over 3. Solve that equation. Okay. Next one, AB equals 9. And we want to find AC and CB. Okay. So you would have to set a variable as x. Let's say AC is x. Then CB has to be 9 minus x, right? Because when you add them together, they make a total length of 9. And now you can use the power of a point formula. If you multiply x times 9 minus x, you have to get 2 times 10. 9x minus x squared equals 20. 9x equals 20 plus 20 equals 0. And then if we factor this, we have x minus 4, x minus 5. So x can be 4 or x can be 5. But remember, AC has to be smaller than CB, which means that we're going to have AC equals 4 and CB equals 5 here. Any questions? All good? All right. For this one, I want to make sure that you know that x is this length right here. Right, so we have 10. Find x if AB is 20. So the power of a point formula is that if we take this tangent and we square it, this equals to the secant, the part outside the circle, times the whole thing. Part outside times the whole thing. Remember that. Okay, so the part outside, what's that? That's 20 minus x, because the whole thing is 20. And the whole thing is 20. So it's going to be 20 minus x times 20. And this must equal 8 squared, so you can just 64. You can basically divide everything by 4 to make it easier. 16 equals 20 minus x times 5. And 16 equals 100 minus 5x. X just be 84 over 5. All right. Next one. Basically, I have chords x, y, a, b. Intersect at q. So AQ is 4, BQ is 6, XQ is 8. So what is XY? Well, to find XY, we have to find QY, and then we just add that to 8. So what's QY? Well, we can use the power of a point formula for chords. 4 times 6 has to equal to 8 times, let's say this is x, 8 times x. Okay, so x will be 3. So XY will be 8 plus 3, 11. Any questions? All right, let's go over this really fun problem. Prove the Pythagorean theorem. I think it's always fun to prove the Pythagorean theorem. So use this diagram to prove that a squared plus b squared equals c squared. It's pretty fun. You don't need to show your proof to me. You can just, like once you prove it, just keep your answer and see if well, if you proved it, then you're right. So that's basically how you can check your answer. All right, so what we're gonna do here is we have two chords. We have two chords in this circle. We have this one, we have this one. By the power of a point formula, if we do this times this, that will equal to this times this. Well, this times this is just a squared, right? A times a. I gotta find what this times this is. What is this big long one? Well, since c is the radius, this is c. So this long one is b plus c. What about the short one? C is the radius. So this is c, which means that if this is b right here, then this must be c minus b. So a times a must equal to b plus c, c minus b. Multiply this out, what do we get? C squared minus b squared is equal to a squared. Oh, look, we did it. A squared plus b squared equals c squared. I think it's pretty cool how, like, there's like infinitely many ways you can prove the Pythagorean theorem. It's pretty awesome. So I'm going to skip this one. I'll put that in the homework. I do want to get to a mass points problem. So here it is. It's pretty difficult, so I'll give you the rest of the end of class to figure this one out. All right, so I don't want to take up too much of your time. So I will go over this one now. So we want to, so this problem doesn't give us a diagram. We have to draw it ourselves. So apparently we have a triangle ABC. Let's draw it like this. Just draw it, however, it doesn't really matter at this point, unless something requires us to draw it in a certain way. But so far, I don't think we need to draw it specifically. Point X is 2/7 of the way from A to B. So it's like, like here. So this is 2, and this is 7, which means that this is 5. So what does this mean? We put A as a mass of 5 and B as a mass of 2. This is how you would balance it, right? Because A is a distance 2 away and B is a distance 5 away. You could just do this. This is how I like to do it for simplicity. If you really wanted to, you really could put any mass here. Like you can put 1 here, as long as the ratios are correct. So if 1 is here, then this must be heavier by a factor of 5/2. So this must be 5 halves. So you can really use any kind of weight. But for simplicity, I like to have integers here, at least. So I will use 5 and 2. Does everyone understand how those weights work? Okay. We have y on the midpoint of BC, so y is here. It balances, right? These are the same, which means that C must be 2. It balances. You don't need any difference in length, so they must, B and C must have the same weight. Now remember the fact. So now we have to connect CX and AY. We meet at P. The area of a triangle APC is 12. So say APC. When I write the square brackets around APC, I'm meaning that's the area of APC. So the area of APC is 12. The area of triangle CAY. That's what we want to find. We want to find this one. Let me highlight it in red. This is the one. This is the triangle we want to find. What's the area? Well, if you notice, APC and AYC, they have the same base. Same base, right? So the only thing that the only thing that's making a difference between their areas is their height. This is the height for APC. This is the height for AYC. And you can see here, the ratio between the heights is the same thing as the ratio between AP to AY. Similar triangles here, right? So the height, the ratio between the heights is the same thing as the ratio between AP and AY, because these two triangles are similar. So all we need to do is find the ratio between AP and AY, and we multiply that by 12. Okay, so obviously AYC is bigger. So whatever the ratio is, we'll try to make it bigger than 12. Okay, so we got to find AP to AY, which means that we're going to use mass points. The mass of Y is 2 plus 2, 4. Mass of A is 5, which means that this length is 4, this length is 5, right? Because the 4 has to be farther away than from the pivot point, which is P, than A, right? So we got to have the ratio between AP and AY must be 4 to 5 then. No, the ratio between AP to PY, right? So make sure we got this. 4 to 5 is the same thing as AP to PY. That's the ratio for AP to PY. Does that make sense? Because we have a mass of 4 on Y and a mass of 5 on A, which means that this must be 4/5 the length of this, right? The mass of 5 has to be 4/5 times closer than the mass of 4, right? So if we have that, then AP to AY is just going to be 4 to 9. This is 4 to 9 because AP is 4, AY is 5 plus 4, which is 9. So AP to AY is 4 to 9. So we know the ratio between the areas has to be 4 to 9. AYC is bigger, so we're going to multiply by 9 over 4 to 12. And the answer is going to be 27. So basically find the area, the ratio, right? This must be the ratio between the areas of the two triangles we want. And since from the diagram we can visually see that AYC is bigger, we're going to have to multiply the ratio we're going to have to multiply 9/4 by 12, not 4/9, because that would make it small. Does that make sense? So you basically have to do mass points here. Just balance them and find the ratios between the sides. And you also have to connect this to what you know about finding a triangle's area. Any questions? There are none. See you guys next week then. Mathcounts chapters in 2 weeks. Make sure you have that in your mind, okay? I'll see you next week.